Welcome and thanks for joining me for this session. We're going to talk a little bit about consensus protocols in this session and basically around private blockchains specifically, but we'll talk a little bit about how these apply in the public context as well and how those were some of the roots for where the private stuff actually came from. So basically, I'm going to talk about some of the core concepts around a consensus protocol. A lot of people, these are fancy words around what consensus is. Really what it is a majority voting to basically determine the state of the ledger. So underneath blockchain is an immutable ledger, as we all know. And the consensus protocol, when someone wants to make a change to that ledger, has to be approved by a majority of nodes. And so what you're seeing on your screen here now is peers in a network who are basically forming a consensus because essentially as a transaction is brought in, a change that someone wants to make to the ledger, it's basically going to have to be approved by all the people in that network. Now, how many people have to approve it and how quickly that gets approved and these kind of things, these are all the nuances of these consensus protocols or these consensus models. There's a big push to be in a decentralized model, so we don't have just like a one or two nodes or a very small amount of nodes who actually control the power of the network because primarily those things could be hacked and compromised and things like that and compromise the integrity of the entire application or system. So there's also an influence on how fast transactions can flow through the system depending on this consensus protocol. There's a lot of research going on in this space. I'm going to talk about some of the most popular consensus protocols, and then I'm going to show you a little demo about how these actually work. So the first one I want to kind of talk through here is proof of work, which is primarily one that's seen in public blockchains currently today. So Bitcoin, public Ethereum, these type systems are relying on proof of work. Proof of work basically has no privacy on transaction details by design. So essentially what we want to do here is the nodes are going to compete. That's what you hear the term mining. So they're basically competing to say, I want to be the guy who writes the next block. The block is going to contain transactions, and whoever wins that gets to write the block. That's the next block in the chain. The other peers will then follow suit and validate that transaction. And once we have a majority who agree on the state of the chain, this is the blockchain that people are transacting against. And so basically all the nodes need to know all the transaction details. This is a truly trustless network because we don't know who's adding nodes to the system. Turns out it doesn't work as well in the enterprise because in the enterprise people will need to know who's on the network, what nodes are on the network, and who has the power to influence change on the network. And so that's where we would move over to something like a proof of authority consensus. And on this proof of authority, you see there's a slight nuance in the image that you see there on the left side. We basically only have certain peers who are called validating peers or validating nodes. And these nodes are basically designed to do the writing and the approval of the transactions, the sealing of the blocks that happen there. You could argue that there's some centralization to this because there's a finite number of these validating peers. Turns out the enterprise have told us that they actually like that, again, because they have some control over that network. This is not a network where we just let anybody join into. They're very kind of regulated and controlled networks. And so essentially the nodes are staking their identity as part of this. So they're saying, I'll validate transactions. If I turn out to be a bad actor because I've been compromised, then it's my identity that is the penalty here to say, Kale, your validating node is actually behaving in a bad fashion and you could be ejected from the network. IBFT has a slight nuance on the proof of authority. It's a different model. The BFT stands for Byzantine fault tolerant. Much more than we can get into in this conversation, but it's a kind of a mathematical term around this consensus model. Some of the attributes around it are immediate block finality. There's a very low time between blocks, so you can imagine that we see a lot higher throughput with this. Very flexible from adding and removing nodes into the network. And such. Okay, and now what I would like to do is jump into a demo. And the demo I'm going to show you here is a pluggable consensus model. There's a lot of interest in the industry around what's called quote-unquote pluggable consensus models. Ethereum has developed this with GETH, one of their primary clients, so you can basically change the consensus protocol before you start your blockchain up, so you can configure it to use any of these different ones. And in our case, we're going to use proof of authority, but I'll show you where you could configure proof of work as well. With this one. I have this all documented in GitHub, so all the steps are up here. You guys can redo this yourself and walk through the exact same thing I'm going through here. But I already have a machine here with Ethereum installed on it, and we're going to walk through how we build this. So the first thing we would do is create a folder to hold our assets here, and I'm just going to call it dev e3. And then we're basically going to need to create some accounts. If you look into GitHub repo, we're basically the next step, we're going to do this GETH, and we're going to create a new account. So if we say GETH, we actually need to create some directories first. So we'll create our directories for node 1 and node 2. So we have those two directories there now. And then we can say the data directory, and we'll say node 1 account new. So we're just creating a new account, set of keys, essentially, to use for this first node. We'll give it a passphrase, super secret. It's test, you'll see it here in a second. And then we'll do the same for node 2. Great. So we have two accounts created there now, offline. We haven't fired up any blockchains or anything yet. And what we'll do with these now is we need to write those into a file because we're going to need them later. So we'll grab these addresses. We're going to write those into accounts.txt. Great. We'll also write our password to a file because we're going to use that when we bootstrap our node. Password was test. Great. So now you can see we have our two nodes. Inside of there we have our keys, we have our password, and we have our accounts file. And if you're following along over here, the next step is we would use Puppeth. So Puppeth is a tool that allows us to basically, this one's been customized for Ethereum private network. And so basically we have to give it an identifier. So we'll give it dev3. And you see we get this little menu system. It's like a wizard that kind of walks you through this. So we're going to configure a new Genesis file. And here's the cool part. So you can see which consensus engine do you want to use. ETH hash, which is proof of work, or click, which is the proof of authority. In our case, we're going to choose option 2. It's going to say how long do you want those blocks to take. Now, if we chose ETH hash, we wouldn't have these questions because obviously we don't control that speed over there. But by default, we're going to do this. We'll say 5. We're going to need to get those accounts out. So what we're going to do for that, I'll just come down here and we'll go into our dev3 folder. And these are our accounts. So we'll just grab this guy. And we'll do the other guy as well. So let's go ahead and grab this one. Great. So we have those two accounts in there, and they said which one should be pre-funded. We're going to do both of them again. Just give them some ETH. And this is basically like bootstrapping your Genesis block is what we're defining here. What's the name of your chain? I'm just going to give it 1010. And we're pretty much done. So the next thing we want to do, we'll just say manage, and we'll say export, and it'll say what you want to name this thing, and we'll just call it the genesis.json. And then we can exit out of here. And if you look now, we'll clear our screen here. You can see we have a Genesis block. So it's a Genesis definition that we're going to use to basically generate our Genesis block. Again, if you're following along, all these steps are up here. The next step is we need to initialize each one of our nodes. So we're going to go ahead and say geth datadir, and we'll do this for each node. And we're going to say init, and we're going to give it that Genesis JSON definition that we just created. And we're not starting a chain or anything here. We're just telling it, hey node, here's the Genesis that you should use, the configuration for your Genesis. So those are all created now. Next thing we do is create a boot node. And we'll do this in the top screen. That's why I'm using tmux here. We're going to run our boot node in this top pane, and then we'll run the two nodes down here in the other one. So basically, let's just clear our screen here. We'll do a boot node. Great. So we just generated a boot key. You can see we generated another file out here. I'm just going to copy and paste this for brevity of time here. And this essentially is going to start up our boot node. Now, a boot node in a peer-to-peer network is very important because this is how other nodes find other people to work with in the network. And so what we're going to do here now is I have this already set up over here. We got to put this boot node over here because we're going to use this as part of our GETH startup. And we also need his accounts again, right? So we'll grab this guy again. And we'll grab the second one. And we're essentially just going to start these up. So we're almost done here. We'll paste that guy in. And what we should see is the P2P stuff starts coming up, and we'll see a ping pong up here on our boot node. So I have the verbosity turned up there. Actually, we need to be in the dev3 directory. Sorry about that. So what we should see is our GETH node start signing transactions. So you can see there's this is basically our proof of authority network running here. We only have one node in it right now. And we're basically going to fire up another node over here in this side. So let's get this guy fired up. And this will be node 2. So we need to go into our dev3 directory again. Oh, I'm already there. Okay. And we'll fire this guy up. And we should see him come up here. There's 2. You can see him coming up as a boot node 2. So this is kind of the demo. I mean, I just used this one. We could basically just shut this down, delete those files, and run public again with ETH hash, and we would have a proof of authority network. So when you're looking to get set up with these blockchains and people complain about how hard it is to set up, I think this was 11 steps to set this up. It's very kind of simplified to do this, and the pluggable model that comes along with Ethereum makes that possible. In the future, obviously we think there'll be more protocols that get plugged into here, and we look forward to those as well to give more choice. So thank you for attending, and we'll have the links along with this video.